Alright, Kara, this is my second attempt making this video. Alright, cool. So we're just going to go through the basic atom of a basic structure of an atom, because it seems to be really important for your exams. I know it's not very long away. We're going to be quite quick through this. I've only got 10 minutes on this. So basically, an atom is, if you break down every element or compound to its smallest constituent part, it should be an atom. Well, there's smaller parts, but for the science purposes, this is the smallest it gets. Alright, so in your basic atom, you have three subatomic atomic particles. You have your neutrons, you have your protons, and you have your electrons. Yep, I have this. Focus is better. Your neutrons, so your protons are positively charged. Your electrons are negatively charged, and your neutrons, they have no charge. Yeah. Alright, how they're arranged in an atom. In your nucleus, you have your protons and your neutrons clumped together. Alright, so your nucleus is positively charged. Yeah. Now, this is where it gets really important. Your electrons are attracted to the protons, because remember, electrons are negative, protons are positive, so those two attract each other. And so how does this look in an atom? Well, depending on the element, it could be carbon or nitrogen or anything, they will have different numbers of electrons and protons. But just for anyone, if it has electrons, then it creates different orbits. So in the first orbit, this is basically, if you have two electrons in an atom, then they will go here, yeah, because they're attracted to the negatively charged, positively charged protons in the nucleus. So in the first ring, the first orbit, this is what this is called. This is called an orbit. This is like, when you have, that the Earth and the planets revolve around the Sun. This is what happens. This is what happens to the atoms. So, if there are enough electrons, the first two electrons will orbit the nucleus. Now, if the atom has more than two electrons, then they will go on the second ring. Yeah, and this can go up to 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then they will orbit around there. Now, if an atom has even more than, say, 8, 10 electrons in its makeup, then they will go on to the third ring, and this can take up to 8 electrons as well. And for your syllabus, you only need to worry about these 3 orbitals. They can go up to, a lot of rings, okay? Because some elements have lots and lots of electrons, but you only need to worry up to you only need to worry about elements which have 1 electron up to 20 electrons in their structure. Okay. All right. Let's move on. Now, this thing's already made. In your periodic table, you will have all these elements written like this. So C is for carbon. You have a number at the top, a number in the corner. The number at the top is also known as your nucleon number, or your atomic mass, atomic weight number. No, sorry, atomic mass number. And that means that's the mass of your protons and your neutrons and your electrons all put together to give that. This number is also known as this number down here is a bit confusing. Is known as your proton number, electron number, or atomic number. It's all the same thing. Okay, that tells you the amount of protons, which are these things in the middle, and electrons, which are these things on the outside, which are in carbon. Okay, that's the same for neon. That's the mass of the atomic mass, or the nucleon number of neon, and this is the amount of electrons and protons in this atom. Okay. All right. So we're going to try and draw the electron arrangement of all these structures. Okay. So, for instance, you had hydrogen. So let's just go through. This is your nucleon number, and this is your proton number. So this is telling me this hydrogen has only got one electron. So I can draw its nucleus, which is there, and it's only got one electron, so that electron goes here, and that is the atomic structure, or that's the electronic structure of hydrogen. So you have your nucleus with the protons and neutrons in the middle, but it's only got one electron, and so that goes there. Okay, let's go on to helium. Same thing again. Oops, sorry. Camera malfunction. There we go. Let's go on to helium. Yeah, this has got 4. That's its nucleon number, and this is its electron number. So I can draw the nucleus again with the protons and neutrons in, and I know this has 2 electrons. So that's the electron instruction of helium. Now let's go on to nitrogen. This has got 7 electrons in. Okay. So as I said before, the first 2 go in the first ring. Yeah. If the element has more than 2 electrons, which this does, it has 7, then those start to go in the second ring. Yeah, so I've already got 1, 2. 2 minus 7, I've got 5 left to fill in. So I've got 1, 2, 3, 4, 5. That is the electron instruction of nitrogen. Okay, let's move on to sodium. This tells me it has 11 electrons in. Okay, let's go through that. So that's the nucleus. The first ring can take 2 electrons, but this has got 11 electrons. Okay, so I go build it more. So that's 2, 4, 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 electrons there. But hold up, it's got 11. So I've got to draw another ring for 11. Okay. Remember, these 2 rings, this ring here and this ring here, can take up 8 each. You only move on to the next ring once you've filled up each shell, each shell, with the maximum electrons it can carry. So this one can only take 2, so that's been filled up. You go on to the next shell. That's been filled up because it's got 8. Then you go into this shell, and you've only got 1 left. So this is the electron structure of sodium. Okay, so if you think back to this diagram, depending on the actual information you get from the periodic table, it will tell you how many electrons need to go in the first shell. So for instance, sodium, 2 electrons went in the first shell, and then it says, and then that means you can go into your second shell, and then you filled up all the 8 electrons need to go there, but that's 10 electrons altogether, but you need to have 11 electrons, so you need to draw the other shell and stick another electron to give you 11. Okay? Excellent. Alright, well, and this is basically the basic look of all electron structures. So if you go through all the entire periodic table, it should be like that. So let's just look at the periodic table.